All right, let's get started. I would show a bunch of code. So if you guys want to move front, that would be better because it's a lot of code I will show. So if I magnify, there will be code out of the screen. So, okay. While the guys get reseated, let's get started. I'll be talking about writing a full stack Scala web application. So about me, I'm sure you got the intro. My name is Pathikrit. I've been writing Scala for a long time. I maintain the Better Files library, and I wrote the array DQ implementation in the 2.13 lab Scala standard library. So that's my background. Okay, so the goals for this talk. First, we will develop a toy web application. We'll write only Scala. So your CSS, your HTML, your JavaScript, your AJAX, obviously your backend. We'll write only Scala, just for fun. We'll have type-safe RPCs. So when your front end calls a backend API, you would get compile errors if things don't match up, like your backend API doesn't implement the interface that your front end is invoking. We'll also show the benefits of doing full Scala for front end and back end. We'll be doing code sharing. So you can share your model classes, your case classes, your validation logic between the front end and the back end. Again, this is a little hand wavy, but there will be minimal abstractions. So we're not going to use anything fancy like cats or ZIO. We're just going to be writing vanilla Scala. It's relatively unopinionated. So if you don't like the JSON serialization library I'm going to present in this talk, you can throw it out, bring your own. Or if you don't like the web serving library I'm going to use, you can throw it out, use it on your own. So it's relatively unopinionated. It's more about how you should structure your code and how you can quickly get something up and running. And again, I'm not presenting a library. I'll be presenting less than 100 lines of code today. Okay, so let's do a demo. I'm going to show you an over-engineered mortgage calculator. This doesn't matter. So this is my IntelliJ, and I'm going to just start my... You don't have to look at this code. I'll present it. So I'm just starting my SVT server, and in my Chrome, I hit localhost. Yeah, so that's my fancy mortgage calculator. And this is all written in Scala, the backend, the front end. So let's hit calculate, and you can see it calculates my mortgage payment. So I have a loan of $1 million. My mortgage rate is 5%, and I have a 30 years mortgage, and it calculates my monthly payments, the principal, interest, and balance for 360 months, which is 30 years. Okay, so, and it's actually hitting a backend API. So obviously you can do this. This is simple math. You can do it in the front end, but for this talk, I decided to implement the mortgage calculation in the backend. So if we look at the network, it's actually calling this payments API with a particular payload, in this case, amount of $1 million, APR of 5 and in 30 years, and you can see it gets back a response. Anyway, that's the demo. So, okay, so let's talk about how do we structure this kind of a web application. So I like to break this type of project into 4 sections. So the first would be framework. So you can think about the framework as your library. Imagine you're developing yet another web application. You should be able to copy whatever code is in the framework into the new project. So this is kind of the library part, which is reusable if you're developing multiple projects. Second is the shared module. So this is the kind of obvious. It's shared between backend and front end. So usually these are your API definitions, your case classes, your model classes, your validation logic, anything that you want to share. Third is the web, which is, as you can imagine, this is your ScalaJs code, your any code that compiles into the HTML, JavaScript. And obviously you have your backend layer, which implements your backend services. You could split the server part into two parts. One is actually the web serving part, which serves the static assets, the APIs, and kind of the services layer, which has your services. But for now, we can just imagine there's only one backend package. Okay, so this is what your structure is going to look like. This is, again, I'm on 2.13, but I will shortly upgrade this talk to Scala 3. So you have your framework, and you have your shared module, which you make depends on the framework. Your web module, which depends on shared, and server, which depends on shared. So that's how you set it up. One useful thing that I like to do is register a custom command, which does everything. So in this case, I registered a def command, which does Scala format, which, if you know SBT, this tilde uses watches changes in your code base. It does fast optimization, so it compiles your ScalaJs code to JavaScript using the fast. It restarts the server and watches till you hit enter to exit the server. So this is really useful if you're developing code and you just want to write it in live mode where you can see your code change live. So the command that I hit here was sbt dev, and it's monitoring changes in any code I write and serving the changes. So I'm going to use, these are the libraries I'll be using. So I'll use Cask. A lot of the libraries are from the Lee Howie ecosystem, who's in the audience. But it's relatively unopinionated. You could swap out the libraries for something else. So I'll be using Cask for my web server, request to make requests, and for my ScalaJs libraries, I kind of like to split it into these 6 kind of categories. One is pure ScalaJs stuff. So this is how I will write Scala for JavaScript and HTML. Sure, there's a Scala CSS part. There's also, in the Scala JS ecosystem, there's a bunch of JavaScript wrappers. So in this case, there is a jQuery wrapper and a Bootstrap wrapper. You don't have to use them, but if you use very common libraries like jQuery and Bootstrap, it's very nice to have them. The API layer essentially is your API calls between the backend and frontend, your AJAX calls. I use STTP, which is for the HTTP status codes. Is very nice, and I use NewPickle to do JSON serialization, deserialization. Again, I'll show you during the talk that you can bring your whatever library you want. And the shared layer is, again, this is the part that is shared between the backend and frontend, and this is the shared dependencies. So note, all these dependencies, you have to use the ScalaJS versions. So at least in the SBT syntax, you have to use this 100% to get them in. But obviously, if you use other build tools, there's other syntaxes for it. Okay, and this is now the full my build.sbt looks like. I have to enable the ScalaJS plugin for my framework, shared, and web. Obviously, for the server, I don't. And this is it. Okay. Let's go with the structure. So the structure, as I said, the framework part is the part that conceivably, if you're developing a new web application, you can just drag this module and put it there. Or if you like publishing libraries internally, this is the part you would want to publish internally. Again, this is less than 100 lines of code. So then there's the server part. The server part has 2 parts. One is the router, which tells you, given an HTTP URL, what to serve. And you have your services part. In this talk, we will implement the mortgage API. So I have mortgage API implementation.scala. In my shared module, I have mortgage.scala, which is a bunch of case classes and validation logic. And in your web package, in this case, this is the homepage, which I'll have this written in Scala. So this is, again, mortgage calculator.scala. Okay, let's talk from front end to back end. So first we have how do we write this web page? So we're using the ScalaJs library, which comes with a lot of helpful HTML tags. So this is what your Scala looks like. So you can see these are a bunch of HTML tags. Each of these tags take a variable number of modifiers. So a modifier, we use this DSL of charset : equal to a string. That's like the most common way, but you can define your own modifiers. And this compiles. So if I do webpage.html.render, I get back a string, and the string is actually this HTML. So this directly translates to this. A little unfortunate thing that happens is you would encounter a lot of HTML keywords are also Scala reserved keywords like for and class and type. You would have to escape them with the backticks. This is a thing that you have to do, which makes the code look a little ugly, but okay, you're still writing Scala. Okay, so this is what you get. All right, so what's the benefit of doing this? Like, we could have just written the HTML. So the biggest benefit is, since you're writing Scala, you can abstract away common things. So in this case, I created an abstract class page, which has all the common things put away. Like, for example, if I'm always using jQuery and Bootstrap, I can just put it in a def, which I can override. And if I always have the same header, which is line 20 to 24, I can move that away. So this gives me the flexibility of, now if I wanted to write a page, I can just extend this framework.page, and I just have to implement the one abstract method, which is render body, and that's it. This is all. So this is essentially like HTML templating, but I'm using abstract Scala classes to not repeat myself. One thing I would like to mention is this little JS export thing. So JS export basically tells the ScalaJs compiler what is publicly available for me to invoke. So this init is the only public. This is not a library. You don't have to do this, but I like to do it because this lets me have a method that gets invoked on instantiation. So you can see on line 17, I'm actually invoking inside a script tag in JavaScript this init method. So whatever is inside it will get compiled by ScalaJs into a function call, into a block that gets invoked when the page is started. So this gives you an option to just describe scripts right away. So in this case, I'm using the init method. So saying, again, I'm using the jQuery wrapper to attach a click handler to this button that I described above here. So this has a push me button, and when I click on it, it just prints a random number. So this is super useful because this gets invoked right away on page load. And another annotation that to keep mind of is the JS export top level. So this actually gives the namespacing of, so when you call init, it knows, like, if you have multiple pages, which init to call, because it actually calls $name.init. So this name is actually this name. So this is a little, again, you can probably write more code around it to not repeat this string, but this helps with the namespacing. And as you may have noticed, I'm writing code that looks like jQuery, but this is, again, Scala. This is the one of the wrapper libraries on top of jQuery that I'm using. But again, you can also dive down into native JavaScript. Okay, let's talk about front-end dependencies. So how do I pull in front-end dependencies like jQuery and Bootstrap? So instead of using like a front-end package manager, nowadays it's pretty common to use CDNs. So here it's just 3 lines of Scala code to essentially have a very prototype of a dependency management system. So here you can just use JS Deliver CDN to grab your CSS and JavaScript. So almost all libraries, all open source libraries and all versions are available here. So in this case, I just define them as tags, and I have helpful method, which takes in the library name and the version. And this is how I use it. In this case, I say like my jQuery is a JavaScript library, and I give it the version number, and that's it. That's all I need to do to declare to manage front-end dependencies. There are many dependencies you would encounter where you would have both the CSS and the JavaScript, like Bootstrap. If you want to include Bootstrap, it comes with a CSS and a JavaScript. You can use this kind of namespacing where you just make a Bootstrap object and declare the version and reuse the version to have CSS and JavaScript tags available to you. So again, this is essentially three lines of code to have front-end dependencies. Okay, so let's talk about, so this is the final code of my mortgage calculator. You can see I'm using my abstract framework, abstract page class. And this is nothing to go over besides it's just I'm writing Scala, but it looks very similar to HTML, and it actually compiles down to HTML. But this highlights one of the benefits of writing Scala is I can write my methods which return helpful to not repeat myself. So this is again like templating. So in this case, I have a def input. So it does this thing where it wraps up the label and the input inside a div and returns the whole thing. So I'm using this input here. So again, so this is just given an input. It gives the title, the text box, and a default number in it. So that's what it does. It has a label, like some ID of the value, and a default number in it. So this lets me easily, this would have been like 15 lines of code, but it's now 4 lines of code because I'm using a def. Okay, so this is all the markup of this web page. So that's all. This is it. So this is all the markup. So how does the calculate happen? So this is how the calculate happens. Where again, this is the init method. On my initialization, I attach a click handler. So the click handler is a Scala function that I attach to the calculate button. So yeah, so this is when I click on this button, a Scala function gets invoked. So this is the signature of the Scala function. So again, I'm using jQuery to do this, but you can also go down to native JavaScript and attach additive and listener. But the jQuery syntax is a little nicer. Okay, so here I read the values. So I read the amount, years from the text fields. This is a little ugly because I am using jQuery value and I'm typecasting it. Then I'm just using toInt or toFloat. I will show it later how a nice way to get around this, to write this slightly nicely, but let's not get hung over on that. The magic happens here. So I am creating an instance of a case class mortgage, and I'm calling the mortgage API. You can see I'm not really writing AJAX code or creating JavaScript JSON objects, but I'm actually writing Scala API, a Scala API method, which translates into an AJAX call. And I get back the result, and I output the table. Okay, so how does this work? So let's go over the shared part. So this is the beauty of writing both backend and frontend in Scala. I'm able to share my model classes. In this case, I'm sharing my mortgage class, my payment class, and I'm sharing my API signature. In this case, my API has 2 methods. One is monthly payments, which given a mortgage returns a sequence of payments. And I have another API, let's say refinance, which given a mortgage and a new rate tells me how much money I can save. Okay. But to make this work, I have to write it a little differently. So instead of this straight API, this is what a Scala programmer would expect to write, but there's no way this will translate to a AJAX call. You have to write it like this. I'll go over this new RPC class. It's a neat way of defining APIs that are type safe. So in this case, instead of def monthly payments, I create a val payments, and I declare a new RPC, which takes the input, which is the mortgage, and the output. So in this case, the input was mortgage and output was sequence of payments. For the second API, my input was a mortgage and a double, and that's what this is. And I said this lives at this route. Okay, so now let's implement this RPC class. Okay, so this is what the RPC class looks like, essentially. It has an input and an output, and it has the capability of being JSON serialized and deserialized. In this case, I'm using NewPickle, so which has the read writer type class, but you can use Circe, or most JSON libraries will give you type classes. So you just have to make sure the input and output can be encoded and decoded to JSON, and a path. And you have the apply, so you can implement, given the input, you get the future of the output. Okay, so let's implement this. Guess what? This is it. So all you do, you do a post on the URL, the path that was specified. This write is basically encode your input into JSON. And when you get back the response, you read it back into JSON. Obviously, for this example, I'm using post, but you don't have to. You can write, if you pass in one extra method, HTTP method, you can also do a get. And if you're doing a get, you have to encode the input to your backend API in the URL, because gets don't really have bodies, or most middlewares don't like if gets have bodies. And the post remains the same. So this way you can implement gets, deletes, puts, but for this example, I'm just going to show post. Okay, so this is it. This is 6-7 lines of code, and I've implemented a way to define RPCs that are type safe, that lives at some endpoint. Okay, let's go over the JSON read write. So again, I'm using NewPickle, so which comes with macros for serialization, deserialization of case classes. In this case, you just put this implicit val, and that's it. This is same for most Scala JSON libraries. You have to stick in an implicit val, like for Circe or other JSON libraries. So this is going to be very similar if you use some other library. Okay, this is the least interesting part. This is my service layer. So this is backend code. Obviously, this could have lived in the front end. There's nothing interesting happening here. But for the purpose of this talk, this is in the backend. I implement the mortgage API. In this case, I have the def payments, which takes in a mortgage, returns a sequence of payment, and also calculates the refinance penalty. Obviously, I'm not going to go over this, but again, to reiterate, the important takeaway from this is this lives in the backend, and this will be invoked by the front end. Okay, so let's talk about the server. So the server serves your given a URL, it serves stuff. So in this case, I'm using Cask. Again, you can use your favorite HTTP serving library. I personally like Cask. So in this case, you can say if I do a get on the homepage, I get the mortgage calculator. So this says if I hit localhost, this is what I get. For the static files, the JavaScript files, I'm actually serving it out of my target directory. So when you use SBT, it compiles to the submodule target Scala 2. Whatever your Scala version. And since I'm running it locally, I'm using the fast optimizations. That's the command I registered. So it actually lives in web-fastop. But in production, it may live in some other directory, or however you package your, if you do SBT assembly to create an Uber jar, it will live somewhere here. Okay, and so that's the two things: how to serve the homepage, how to serve your JavaScript. And the last is how do you wire all the API calls. So remember that we registered back here all the RPCs, but how do they get served? So we're going to use this annotation of cask.post saying any subpath of /API. Again, this is just a convention I'm using. You're free to use whatever convention works for you. Will be routed to. So in this case, my API definition, this RPC definition of payments, is actually implemented by my backend mortgage API implementation.payments. I will go over how RPC.wire and this squiggly right arrow is implemented. I know symbols are now frowned upon in the Scala world, but I think this was appropriate usage here. And similarly, so mind you, again, to be clear, on the left side, these things are my RPC definitions. So these are just definitions, which are these definitions. And on the right side is actually the implementations of definitions, okay, which is here. So this is in my in my backend server, and this is in my shared module. Okay. Okay, and this is it. I have showed you how things are served, how the APIs are wired. So the last thing I need to show you is how this RPC.wire and how this arrow is implemented. Okay, so let's talk about one thing at a time. So a useful thing to declare is this type, which is a partial function of a request to a response. So I'm using Cask's request and response classes. But again, if you have your own library, you probably have the same to denote a request and response. So in this case, a request handler is a partial function from a request to a response of JSON. So this just means that given a request, it may respond back with the JSON. That's all that it is. But this is pretty useful. So what does RPC.wire do? So this is, again, this thing, RPC.wire. It takes a bunch of request handlers, which are these partial functions, and it chains them. It basically does try the first request handler, or else the second one, or else the third one, so on and so forth. And if nothing works, then you say errors not found, and error is this thing, which is, again, a particular response with a status code. I'm, again, using Cask for creating my response classes, and the status codes are from STDP library. Okay, so that's what RPC.wire does. So the last thing to show you is what is this squiggly arrow thing. So this thing is implemented, again, this is a function of my RPC class, which takes in another function. So in this case, this is my RPC, and this is my squiggly arrow. And this says, given this RPC, how is it implemented? So you have to, and it's completely type safe because it uses the same input and output type parameters, because my f has to be a function of IO. And it returns a partial function. So it may be able to satisfy the request. And it can only satisfy the request if the request path matches the path that I said this API is declared on. So in this case, I can only respond if my API lives at this URL. Okay, so what do I do? So if the request.path matches the path that I declared, I try to JSON read the input data. If I succeed, I try to invoke the function. So again, to be clear, this function lives in the backend. So it's actually invoking the backend function. And if I fail to invoke the backend function, I respond back with a 500 error code. Else, if it's a success, then I JSON write the output back. So this is, again, everything is type safe because my RPC defined on type parameters I and O only accepts a function of I and O and returns a partial function which says I can only do this if the path that I've been invoked on matches the path that I was declared. And this is it. So this is all the code that's needed. I've showed you all the code that's needed to implement a full stack Scala application. So most of the magic is in this line of code from line 9 to line 18. It's not really magic. It's just chaining together an RPC definition with a backend implementation. Okay, so use cases, the one is like internal apps. The biggest use case is if you already have a Scala code base, it's really easy to throw in like admin pages for your microservices or your batch services. You don't have to write separate admin APIs and separate UIs. You can just write it in Scala and package it, deploy it on a port, throw an Nginx in front of it, and that's it. You don't have to have a separate code base. So imagine if you have microservices, you want to write some administration APIs, or if you have a long-running server and you want to do something on it with a nice UI to look at things or do some admin operations. This is it. You don't have to write anything else. You just package it as part of your Scala application. Another thing is you can share a lot of code. Like if you probably have a lot of backend validation logics, backend model case classes, you can share it with your front end. And you can obviously use for fun personal projects. Over the pandemic, I used something like this to develop my own home automation thing. So it was fun. I'll quickly go over like shared validation. So this is an example. This is 25 lines of a validation library. Obviously, there are fancier libraries out there, but you can build your own validation library in like 25 lines of Scala. This is all you need. You can then use it as like you have a case class address, and you can write your validations, like implicit validations. You can say like the street address must be this, country must be that. If you have a person case class, you can even write nested validation saying if a person has an address, the address must also be valid. And now you can share the validation. So in this case, all you have to do is, this is the arrow function. You just have to stick one in here saying, oh, if I have an input validator defined, let me try to validate my input. So this works beautifully both ways because your front end will not make the API call if it fails the validation. And your backend will also do the validation logic because you don't have, someone could be using curl to use the API, call your API. So you still need to do that validation in the backend. But the cool thing is you're sharing the same validation code in front end and back end, essentially using just three extra lines in your RPC function. And yeah, this is how, like in this case, if I'm talking about mortgage, I can override and provide a validation for mortgage saying like the API, the mortgage rate should be greater than 0 or something like that. I'm running out of time, so you can also write CSS using Scala. There's an excellent library called scalacss. Again, you can stick this into your abstract page class, so you can then override your styles. And in this case, this is the kind of a DSL that the Scala CSS library uses. This essentially compiles down to this thing. Again, you don't have to use this, but as promised, I would write only Scala for this talk, so even my CSS is in Scala. So lastly, one util, I mentioned like this is pretty annoying to read an int out of a jQuery input element because I have to do this 5-level hoop to first cast it as string, then to an int. What I would ideally want to write is this thing. Maybe even I can just say like I want to read a case class mortgage out of these 3 input fields. You can do that. This is all the code you need to write. Again, this is not necessary. You can still write the ugly as string and then cast it. But this is pretty useful, I found, everywhere. Essentially, all ScalaJs code returns a disjunct type, at least in Scala 2.13. It's this or thing, which says it's an int or a float or a string or a boolean. And you just provide implicit. It's essentially a read type class, which says, given something, how can I read an int from it or double from it? This is pretty useful to write this type of code. Again, it's not required. So again, at the end of my talk, so I'll quickly go over all the things you saw. So jslibs.scala is the CDN front-end library management. jsread.scala is the little utility I just showed to read JavaScript instances into Scala types. This is my abstract page class. This is my RPC util. This is my validation library. And that's it. And this is my router, which serves web pages. This is my backend that implements the mortgage API. This is my shared case classes and validation logic. And this is my front end, HTML and JavaScript. And that's it. I only wrote Scala. And you can check out the sources on GitHub. You can clone it, start your own front-end Scala project. That's it. Last slide, we are hiring. I work in a quantitative hedge fund in New York, but we're hiring anywhere. So talk to me if you're interested. Thank you.